Hi everyone. So in this video we are going to start our new chapter, that is number system. Now in number system first we will study number system, then we will study the operations, then we will study the codes, then we will study the operation of the codes, and then we will see the complements. So basically these five topics are there. You can tell the chapter name as number system and codes. So this is the complete chapter name, number system and codes. So those we are going to study. Now while studying this particular chapter, you might have some doubt that sir, we are doing it, but where we will be using it? This question will be coming, sir, where we will be using it? So where you will be using it, that answer will be given in the next chapter, that is combinational circuit. So when you are done with the combination circuit, your all the doubts will be answered, that sir, where we will be using it. Here you will be understanding the concept, but the question that sir, where we will be using it, that will be answered in the next chapter, where you will use it, why we are studying it. So here I will tell you certain things. You need to accept that we are studying that thing. Where we will be using it, that you will study later on. Okay. So let's start with the number system. So there are different kind of number systems. So first one is the decimal, that we already know. Decimal number system we already know. Let's just say what is the base of decimal number system, that is base 10. Why do I call it base 10? Because there are total 10 number possible. 10 digits are possible. 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. These 10 digits are possible in binary number system. Sorry, in decimal number system. Let's just say there is some number written 93. So I have made this number from using 9 and using 3. So 2 digits I have used, that is 9 and 3. Right? So there could be examples. Basic what we already know, that is example is 93. Right? So here 9 is there and 3 is there. So this number is acceptable. If I write example 127, so this number is also acceptable because 1 digit is used, 2 digit is used and 7 digit is used. So this number is also acceptable. But if I write A32, so you know that there is a digit called 2. There is a digit called 3 as well. But there is no digit called as A. We don't know what is A. There is no kind of digit called as A. So this is not acceptable. This is not a number. A32, when there is base 10, A cannot be a number because maximum number can be 9 only. Maximum we know till 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Maximum we can go till 9. You will not say, sir, here you have used 12. No, I did not use 12 here. Here I have used 1 and 2. Right? This is not 12. So no one will say that, sir, the number is 12 here. So you have used 12. Nah. I am using digit 1, digit 2 and digit 7. So we know all these digits. We know 1 as well, we know 2 as well, we know 7 as well. But we do not know what is A. So this number is not acceptable. In binary, what is the base? Base is 2. Base is 2, that means only 0 and 1 are known. Nothing else. That's it. 2 base means there will be only 2 numbers that are 0 and 1. So only 0 and 1 are known. So if I write a number which is 0, 1, 0, will this be acceptable? Yes, surely. If I write another number, let's just say 100, will this be acceptable? Yes, I know all the numbers. If I write this number 210 and I say the base is 2, will that be acceptable? No. This will not be acceptable. Why? Because you do not even know the number 2. If the base is 10, that means you know only 0 and 1. If the base is 2, that means you know only 0 and 1. If the base is 10, that means you know from 0 to 9. But now you do not know 2 because the base is 2 only. So you know 0 and 1 only. If base was 10, that means you know from 0 to 9. If base is 2, that means you know from 0 to 1 only. So this is not acceptable. Or 720, this will also not be acceptable because you do not know 2, you do not know 7. This will also not be acceptable. Octal means base 8. Base 8 means how many numbers would be there? You can write it on your own. 1, 2, 3, 4, 5, 6 and 7. Till 7 will be acceptable. So what all the examples can be there? If I write 723. So yes, that is acceptable. I know 7, I know 2, I know 3. But if I write 982, will that be acceptable? No. Why so? Because I do not know I do not know 8, I do not know 9. So that is not acceptable. If I write 777, will that be acceptable? Yes, because I know 7 I know 7 and I know 7, so that will be acceptable. Hexadecimal means base 16. What do you mean by base 16? From 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 till 9, and then 10 will be there, but 10 we cannot write 10 because 10 is made from 1 and 0 only, so we cannot write 10. So we will write A, B, C, D, E, F. Base 16 means from 0 to 15 you will have, right? From 0 to 15. Total 16 numbers will be there from 0 to 15. So 9, 10, 11, 12, 13, 14 and 15. So F is 15. But we will not call it 15 because 15 is made from 1 and 5. So I have to write it in terms of A, B, C, D. So F is 15. Okay. So if I take examples, let's just say I write example of 923 in 16 base. Will that be acceptable? Yes, surely. Why that will not be acceptable? That will certainly be acceptable, right? Because 9 you know, 2 you know, 3 you know. If I write example D, E, F 16, will that be acceptable? Yes, that will be acceptable because D you know, E you know, F you know. If I write the example D 7 F, will that be acceptable? Yes, that will also be acceptable because you know D, you know 7, you know F. If I write H 9D, will that be acceptable? And base is 16. 16 means you can have till F only, you cannot have H. So that will not be acceptable. Are you getting this point? So that's the thing. So if base R is there, that means the number will, these are the most important ones, decimal, binary, octal and hexadecimal. In those only these two are important. And if we are studying digital circuit, then binary is more important. If you are studying mathematics, then decimal is more important. Okay. So base R is there. If base R is there, then the number will start from 0, 1, 2 till it will go R minus 1. And if the example is there in that manner, that there is some alpha, beta, gamma is written with base R, that means R has to be greater than alpha, beta has to be greater, R has to be greater than alpha, R has to be greater than beta, and R has to be greater than gamma as well. Then only this number will be acceptable. Otherwise, this number will not be acceptable. Are you getting this point? The written base has to be greater than all these values, alpha, beta, gamma. Then only it will be acceptable. If it is even if it is near, it is near, that is, let's just say 2 is there. So even if it is near means even if it is equal, then also it is wrong. It cannot even be equal. It has to be greater. Okay. And yeah, other examples, let's just say here I take example of point that I did not take. So if I am writing 72.32, yes, certainly it is acceptable. Later on we can take the example. Here we can take the example. So in the example, if I take in point, if I take 729.32, this is acceptable, right? But if I take 8D2 point F3, this is not acceptable. If I take 794.3B, this will also not be acceptable because all the number has to be in the base 10. So in points as well, it will follow the same thing. In points as well, it will follow the same thing. Just whatever the number you see, you should be knowing that number. So in 10 base, I do not know what is F. In 10 base, I do not know what is B. So all these are not acceptable. Now tell me one thing. If this number is written 2743, can I write this number as 3 into place value of 3? What is the place value of 3? 10 to the power 0 plus 4 into place value of 10, that is 10 to the power 1. Sorry, place value of 4. 4 into place value of 4. 7 into place value of 7, that is 10 to the power 2. And 2 into place value of 2, that is 10 to the power 3. So I can write it in this manner. So basically it is 2000 plus 700 plus 40 plus 3. And if you do the calculation, you will get the same number. Say yes or no? And the number you are getting in decimal, because the calculation that you are doing is in decimal. This calculation, whatever the calculation I know, that is there in decimal only. So you are getting the same number. Similarly, how will you write this? You will start from this point. You will start from this point. What will be the decimal value of this one? That would be 10 to the power 1. What will, sorry, this would be 10 to the power 0. What will be the decimal value of this one? That would be 10 to the power 1. What will be the decimal value of this? 10 to the power minus 1, right? Because if I write 3 into 10 to the power 0 plus 4 into 10 to the power 1 plus 5 into 10 to the power minus 1. So that would be 3 plus 40 plus 5 into 10 to the power minus 1 would be 0.5. So what I am getting? 43.5. Okay. You can write it down on your own. So what that would be? 9 into 0, 1, 2, 3, 4, 5. So 9 into 10 to the power 5 plus 7 into 10 to the power 4 plus 3 into 10 to the power 3 plus 2 into 10 to the power 2 plus 5 into 10 to the power 1 plus 6 into 10 to the power 0 plus 5 into 10 to the power minus 1 plus 3 into 10 to the power minus 2 plus 7 into 10 to the power minus 3 and plus 4 into 10 to the power minus 4. Basically, we start from this point and we take base 0, 1, power 0, 1, 2, 3, 4, 5, 6, power minus 1, minus 2, minus 3, minus 4. In that manner we go. Okay. Let's remove it. Now similar thing if we are doing in base 2, that is binary. Let's take some examples which is acceptable. 110.0101 if base 2 acceptable. If I write 110.201 base 2 not acceptable because the number 2 I don't know. If I write 310.21101 not acceptable because number 3 I don't know. Here as well the same thing is there. How you can write it? What is the place value of this? 2 to the power 0. What is the place value of this? 2 to the power 1. What is the place value of this? 2 to the power 2. And what is the place value of this? 2 to the power 3. Here the base was 10. That's why the place value was 10 to the power 0, 10 to the power 1, 10 to the power 3, 10 to the power 4. Here the base is 2. That means these are the place value. So 1 into 2 to the power 0 plus 0 into 2 to the power 1 plus 1 into 2 to the power 2 plus 1 into 2 to the power 3. So what you will be getting? 1 plus 0 plus 4 plus 8. Now you will say that, sir, you do not even know this number in this base. I do not even know what is 4. I do not even know what is 8 when there is base 2. Yeah, I don't know. I am implementing that in decimal. I am representing this binary number into decimal. So what I am getting? So 13. So if 13 is there in decimal, then how it will look in binary? It will look like this. Are you getting this point? 13 in decimal will look like this in binary. 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. So 1 into 2 to the power 0, 1 plus 0 plus 4 plus 8. So that is 13. What about this one? How it will look? So 1 plus 2 to the power 0 plus 0 into 2 to the power 1 plus 1 into 2 to the power 2 plus what will be the base value of this one? Can you tell me? Place value of this, that will be 2 to the power minus 1 and this would be 2 to the power minus 2. So 1 into 2 to the power minus 1 plus 1 into 2 to the power minus 2. So that would be 1 by 2 plus 1 by 4, right? 0.75 and we can add this up. That would be 1 plus 4, 5. 5.75 and this number I am denoting in decimal. So 5.75 will look like this. Okay. Let's solve this one. 1 plus 2 plus 4, 8 plus, are you getting this point? What I am doing? 1 into 2 to the power 0 plus 1 into 2 to the power 1 plus 0 into 2 to the power 3. Sorry, 0 into 2 to the power 2, that is 0 only, plus 1 into 2 to the power 3, that is 8, plus 0 into 2 to the power 4 plus 1 into 2 to the power 5. What that would be? 32 and plus 1 into 2 to the power 6, that would be 64. Now what I will do? 1 into 2 to the power minus 1, that would be 1 by 2 plus 0 into 2 to the power minus 2, that would be 1 by 4 plus 1 into 2 to the power minus 2, that would be sorry, 1 into 2 to the power minus 3, that would be 1 by 8. Got it? Right? So let's solve it. We can use calculator. Why should we use our brain when you are having calculator? 40, 104. 104 plus 3, 107. This is very easy. 107. What is 1 by 8? 0.125, right? 0.125 plus 0.5, that would be 0.625. So that's it. I did not use calculator. Okay, let me check it again. 104, 104 plus 3, 107, and 1 by 8 is 0.125 plus 0.5. Yeah, 0.625. No, you need to use calculator. We are smart. Look, I am really on low confidence when it comes to calculation. Okay, I am not that confident in calculation, so that's why I always use calculator even for a minor calculations, because so that I can avoid calculation mistake in the examination. So 104. So yeah, this is how you will denote it in decimal. I hope you have got the point. 1 into 2 to the power 1 plus 1 into 2 to the power 2. Sorry, 2 to the power 0. From 0 it will start. 0, 1, 2, 3, 4, 5, 6. In that manner we are going. 0, 1, 2, 3, 4, 5, 6. Yeah. Okay. If octal is there, that means base is 8. So from 0 to 7, all the numbers will be there. If we take some examples, what those examples will be? 724. That would be acceptable. Yes. If you take 872.78, no. And if you take 971.33, that is also not acceptable, because 9 number I do not know. That I am talking about base 8. Now, what will be the place value of 2? 8 to the power 0. Plus, what will be the place value of 7? Wait a second. Yeah, okay. 1. What will be the place value of 7? 8 to the power 1. What will be the place value of 4? 8 to the power 3. What will be the place value of 6? 8 to the power 4. You can calculate it and you will get the answer in decimal. Whatever the calculation you do, whatever you get, you will get that answer in decimal. I guess we can calculate it. So 48 plus 52, 52 into 8 to the power 3. So one calculation I will do. So 8 6 ja 48, 48 4 52, 52 into 8 to the power 3, 8 to the power 3 into 52 plus 56 plus 2. So I am getting 26682. 26682, but that is in decimal. Okay. If I have written 1011, will I say that place value of 1 is 2 to the power 0? Is that so? Will I say place value of 1 is 2 to the power 0? No, no, no. I will check the base. It seems like that it is a binary number, but no, you need to check the base. Base is 8, so it is a octal number only. So 8 to the power 0 plus 8 to the power 1 plus 0 into 8 to the power 2 plus 1 into 8 to the power 3. Wait a second. Here this is having base 2. Why I am doing these blunders? And this is having base 3. This is wrong. Sorry. So what we will get? 8 to the power 3 into 6 plus 64 into 4 plus 56 plus 2, 3386. 3386. Okay. Here 512 plus 9. 512 plus 9. 521. Okay. This would be 512 plus 9. Here base 8 to the power 1. 8 to the, yeah. So we will not be able to calculate this certainly, because it will be a huge number, but we can write down the place values. So we will start from 6. So 6 into 8 to the power 0. This will have 8 to the power 0. This will have 8 to the power 1. This will have 8 to the power 2. This will have 8 to the power 3. This will have 8 to the power 4. What about this one? This will have 8 to the power minus 1. This will have 8 to the power minus 2. and this will have 8 to the power minus 3. So in that manner you can write and you will get your final answer. Okay. Same goes for hexadecimal. Base till f, numbers will be till f. Acceptable number, what that would be? 923.f e. Will that be acceptable? Surely. If I write 92g.he, will that be acceptable? No. If I write klp dot 67, will that be acceptable? No. Okay. So 953 base 16. So how we will denote it in decimal? So 3 into 16 to the power 0 plus 5 into 16 to the power 1 plus 9 into 16 to the power 2. So 16 to the power 2 into 9 plus 16 पंजे 80 plus 3. So 2387. 2387 in base 10 I am getting. This is in the decimal because all these are decimal calculation. And what about this? What is f? F is 15. So 15 into 10 16 to the power 0 plus what is d? D is 13. 13 into 16 to the power 1 plus what is 9? 9 is 9 only. 16 to the power 2. This is 16 plus 4 into 16 to the power 3 plus 5 into 16 to the power 4 plus what is C? 10, 11, 12. 12 into 16 to the power 5. So 0, 1, 2, 3, 4, 5. That's it. You will do the calculation, you will get the answer in decimal. Right? What about this one? So here this will have the base 16 to the power 0. This will have 16 to the power 1. This will have 16 to the power 2. This will have 16 to the power 3. And this will have 16 to the power 4. What about this one? This will have 16 to the power minus 1. This one will have 16 to the power minus 2. And this one will have 16 to the power minus 3. And you can add them up and you will get the number in decimal. So if you want to convert any base to decimal, then what is the scene? How can you convert this number to decimal? Tell me. What is the place value of this? 5 to the power 0, 5 to the power 1 and 5 to the power 2. Any value to decimal. And what is the place value of this? 5 to the power minus 1 and 5 to the power minus 2. So you will start from the number which is left to the point. 5 to the power 0, 1, 2. 5 to the power minus 1, 5 to the power minus 2. Okay. So 3 into 5 to the power 2, that is 3 into 25 plus 4 into 5 plus 2 into 1. 5 to the power 0 is 1 only plus 1 into 5 to the power minus 1 plus 0 into 5 to the power minus 2, that would be 0 only. So 20 95 75 और 20 95 95 plus 2 97 97 by 97 plus 1 by 5, that would be 0.2. So 97.2 in decimal you are getting. Okay, 97.2. Okay, 75 20 95 plus 2 97 1 by 5.2. So this would be a bit tough calculation. So what A will have? 0, 1, 2, 3. So A 10 will have 16 to the power 3 plus 2 will have 16 to the power 2 plus 7 will have 16 to the power 1 and F, that is 15, that will have 16 to the power 0 plus this C, that is 12, right, that will have 16 to the power minus 1. So if you calculate this, what you will get? Let's check out. So 16 to the power 3, 16 to the power 3 into 10 plus 16 square into 2 plus 7 into 16. Arey yaar. Let me pause it and do the calculation. So you are getting 41599.75. Okay, let's do the calculation here. 2 into 9 to the power 0. So this is 9 to the power 0, 9 to the power 1, 9 to the power 2, 9 to the power 3. So 8 into 9 to the power 3 plus 7 into 9 to the power 2 plus 6 into 9 to the power 1 plus 2 into 9 to the power 0, and this would be equal to 9 to the power 3 into 8 plus 81 into 7 plus 54 plus 2. So 604.55 with base 10. So from any base to decimal you can convert now. That would be very easy. Now if you want to go from decimal to any base, then how will you go? Like from decimal to base 2, base 16, base 8 and or base r. So let's understand the method by a simple example. So first we will take the example of decimal to binary. The method is same. What you will do? First you will pick this number, that is 73. You will pick the integer part. This is the integer part. So first you will pick the integer part, that is 73. So integer part I am picking, that is 73. Now what is the number here? That is 2. So now I will divide 73 by 2. What we will get? 36 and remainder is 1. So here I will write my remainder. Remainder is 1. I will again divide. What I will get? Remainder as 0. Now again I can divide, right? I can divide by 2 again. What the remainder I will get? 0. Then again I can divide by 2. What remainder I will get? 2 4 ja 8. I will get remainder as 1. Then again I can divide by 2. What I will get? 2 and remainder 0. Then again I can divide by 2. What I will get? 2 1 0. If I divide by 2 again, what I will get? 1 0 again, right? If I divide by 2 again, then I will get the same number because 1 is not divided by 2. Basically this number is less than 2. This number is less than 2, right? So here I will stop. Now what I will do? I will go from down. I will go from down to up. I am going from down to up. So going from down to up, what all number I am getting? 1 0 0 1 0 0 1. Surprisingly from up as well I am getting the same number. But don't get confused. I am going from down to up. Okay, that is a big blunder from my side. From down to up and from up to down I am getting the same number. So 73 can be written in this manner. But we need to do something of 0.25. So what I will do? 0.25 I will pick. Now I will multiply by this base, that is 2. So 2.5 by 2, that is 0.5. 0.5 by 2, 0.50 into 2, what I will get? 1.0. 0.0 into 2, what I will get? 0.00 only. What I am doing? Okay, sorry, I forgot to tell the method. 0.25 into 2, what I am getting? 0.50. So whatever I am getting after 0.5, that I am picking here, 0.50. Then into 2, 0.50 into 2, whatever that I am getting here, that I am picking here, into 2. So I can keep on doing this, 0.00 into 2. So again I will get 0.00 only. So in that manner I can keep on doing it. I need to just do it for 3-4 digits. Okay, that would be more than enough. So for 3-4 digits, but now I will be writing from up to down. Okay, you do not need to do it till 0.00. You can do it for 3-4 digits, 3-4 numbers. Okay, it's not necessary that you need to go till 0.00. Till 3-4 number you need to do. So I am going from up to down now. So that would be 0.01. So 0.25 can be written as 0.01. So this is what? This is 73. And this is what? 0.25. So if I need to write 73.25, so what I will write? First I will write 73, that is 1 0 0 1 0 0 1. I will start writing from the below 1 0 0 1 0 0 point 0 1. That's it. I will start writing from the upward side. Okay. Are you getting this point? We will take more examples. Let's take more examples. We need to convert it to base 8. How will you do it? Base 8. So 739 is there. So first I will pick the 739 part. Now I will do the division. So this I will get 8 9 is 72, 9 2 is 18. So one remainder I am getting. 8 1 is 8, 8 1 is 8. What remainder you are getting? 4. Then again do the division. 8 1 is 8. What remainder you are getting? 3. You will go from down to up, right? So 1 3 4 1. Point something will come. 1 3 4 1. Now point something will come. 0.26 into 8. What do you get? 0.26 into 8. 2.08. 0.08 into 8. What you will get? 0.64. 0.64 into 8. 0.64 into 8. 0.64 into 8. 5.12. 5.12. I just need to look at the integer part only. Now again I can do 0.12 into 8. I can keep on doing it. 9 point, what I will get? 0.12 into 8. 9.6, right? 0.12 into 8, sorry, 0.96, sorry, 0.96. 0.96, really sorry, 0.96. So I can keep on doing it, but I just need to write till 3-4 digits. I will go from up to down. So what is the number I am getting? Only the integer part you need to look. 2050. After point, basically, what will be my correct answer? 2050. Okay, in base 8. So you just need to look at the integer part. 20 here. What was the integer part? 0100. So that I wrote 0100 also I could have written. Basically, in ahead of that I could have written 00 as well. But that is of no use. So that's why I did not write. So solve this on your own for 16. 7932. 7932. 16. Okay. So 7932. Let's divide it. 7932 by 16. What you are getting? 495.75. That means 495 into 16. Here you will get 495 minus 7932. 7932. And here you will get 12. And what is 12? C. 12 is C. This is C. 16. 480 and you will get 15 here. What is 15? F. And again divide by 16. We divide by 16. So 16 1 is 16. And what you will get here? 14. What is 14? E. So if you go from up to, sorry, down to up. So what all number you are getting? 1 E F C. Now in point something will come. So 0.67 into 16. 0.67 into 16. And into 16. That is 10.72. 10.72. And 10.72 will be written as A.72. 0.72 into 16. 0.72 into 16. That would be 11.52. And 11.52 will be written as B.52. 0.52 into 16. 0.52 into 16. That would be written as 8.32. So you can keep on doing that, but till a few steps only we need to write it. Now we need to look at only integer part. Only the integer part. What is that? That is A, B, 8. So in that manner, will you be able to remember how to proceed in these kind of problems? Next problem you will solve on your own. From this to base 6 you need to convert. So base 6, what you will do? 8914. 8914 to base 6. So I will divide by 6. So 6 1 ja 6. 6 चौकी 24, 5 48 3 4. Let me confirm it. 485 into 6 plus 4. Okay. Divide by again 6. 3. 247 into 6 plus 3. 485. 6. 1. Again 6. 5. And then again 6. 6 1 ja 6 and 0 remainder is there. So let's check. 6 1 ja 6, 4, this was correct, this was also correct. 3 1 5. Okay, so let's go from up to down, sorry, from down to up. So that would be 1 0 5 1 3 4. Point I need to write. So 0.73 into 6, 0.73 into 6, 4.38. 0.38 into 6, 0.38 into 6, 2.28. 0.28 into 6, 0.28 into 6, 1.68. 0.68 into 6, 4.08. You can keep on doing it, but let's not do it more for more steps. So you can keep on doing it. You will write from up to down, right? Up to down. 2 4 2 1 and the base 6. Now what you can do, you can cross check as well. You can cross check as well. How you will cross check? 4 plus 3 into 6, that is 18, plus 1 into 6 to the power 2. 1 into 6 to the power 2, what that would be? 36, plus 5 into 6 to the power 3. What is 6 to the power 3? 6 to the power 3 is 216 into 5. That would be 1080. 1080. Plus 6 to the power 4, 6 to the power 5 it would be. This would be 6 to the power 5. So 6 to the power 5. So that would be 7776. And if you add all these, plus 1080 plus 54, 7776 plus 1080 plus 58. So 8194 only you are getting. So this calculation is giving you 8194. Plus you can do 4 into 6 to the power minus 1 plus 2 into 6 to the power minus 2 plus 1 into 6 to the power minus 3. So what that would be? 4 by 6 plus 4, first it would be 4 by 6 plus 2 by 36, that would be 1 by 18. 4 by 6 plus 1 by 18 plus 1 by 6 to the power 3 is 1 by 216. So basically 0.726 you are getting, 0.726. This is what you are getting in decimal, which is nearly equals to 8194.73 only, right? 7 to 6, like if you keep on proceeding, what you will get in 6 to the power 4, 6 to the power minus 4, if you keep on doing that, then you will get 73. But we don't need to get exact, this would be the approximate one, right? So that is our answer. So in that manner you can cross check as well. Okay, let's see conversion from any base to another base. From any base to another base you need to convert. So from 5 to 6, how will you go? What do you think? What I can do is that I will first convert it to base 10 and then I will go to base 6, because I can convert any number to base 10. How can I convert this number to base 10? What that would be? 1 into 5 to the power 0 plus 4 into 5 plus 3 into 5, 5 square, that is 25, plus 3 into 25 plus 1 to the power 1 into 5 to the power minus 1 plus 2 into 5 to the power minus 2. That's it. So 75 plus 20, 95 plus 1, 96, 96 plus 0.28, 92.8, 96.28. This is in decimal. Now we need to convert it to base 6. So how will we convert it to base 6? So 96 0 9 16 into 6 is 96 only now. Yeah, then 6 on just 6 6 to that 12 4. That's it. 240 in upward direction. What about 0.28? So 0.28 into 6. Now we are going to convert it in 6. So we just divided by 6, 240, and here we are going to multiply. So 28 into 6, that would be 1.68. Then 0.68 into 6, 0.68 into 6, 4.08, and 4.08. So 0.08 into 6, that would be 0.08 into 6, that would be 0.48. Then it in that manner it can go. So we will write downward. So what that number would be? 240.140 in base 6. So basically 314.12 in base 5 is equivalent to 240.140. That's the answer. So this is how you can convert any base to another base. First we converted it to decimal, then we will go to the other base. Okay, so that's the way we can proceed. Okay, I hope calculation are perfect. So let's move on to our next topic, that is a special case is there. The special case is in terms of binary. So from any binary number to 2 to the power n number system you are going. From binary to any 2 to the power n. So what 2 to the power n can be? 2 to the power, what is 8? 2 to the power 3. What is 12? 2 to the power 2. What is 4? 2 to the power 0. So from binary to any number you are going, from binary to any 2 to the power n you are going, where n is integer. n belongs to, we should say, natural number. When n is a natural number. Okay, n is a natural number. 1, 2, 3, 4, 5, 6, 7, 8. So from binary to 2 to the power 3 you are going. Okay, this is the binary number. So first we are going from binary to 2 to the power 3. So what we need to do? First we need to check this number. What is that? 3. The number is 3. So from here we will start and we will take the groups of 3. 1, 1, 0, 0, 1, 0, 1, 1, 0, 1, 1, 0, and here only 1, 0 you are getting. So another 0 you can put. So groups of 3 you are taking. Now 1, 1, 0. 1, 1, 0 in decimal, how you can write that? How you can write 1, 1, 0 in decimal? Here point is there, here point is there. Or let's start from here. So group of 3, 3 you have taken. Now let's start 0, 1, 0, 0, 1, 0, 1, 2, 4, 0, 1, 0. This we have already done, right? 0, 1, 0. What that would be? 2. 1, 1, 0. What that would be? 1, 1, 0. 4 plus 2, 6. 1, 1, 0. What that would be? 6. 0, 1, 0. 0, 1, 0. What that would be? 2. 1, 1, 0. What that would be? 6. 0, 1, 0, 1, 1, 0, 1, 1, 0, 0, 1, 0, 1, 1, 0. Point. In that manner, here you will go. So what would be 1, 1, 0? 1, 1, 0 will be 6. This is 1, 1 only, so another 0 you will make. So this number will be 1, 1, 0. The group of 3 you need to take. So 1, 1, 0. What would be 1, 1, 0? That would also be 6. So that is the number in 8. Okay. If I need to convert it to, this was your A, you can say. If I need to convert it to 2 to the power 4, that means 16. So what is the number here? 4. So I have to make the group of 4. So let's remove it off. So let's start from here and make the group of 4. So from point only you will start. 4, 1, 2, 3, 4. 4, 1, 2, 3, 4. 4, 1, 2, 3. So another 0 I will have to make. So 2 zeros I will have to make here. 1, 2 only was there, so 2 0 I will have to make. Now let's start writing. So now you can start writing from anywhere because group of 4 are there. So in group of 4, 1, 2, 4, 8. So what this number will be? 2. What this number will be? 1, 0, 1, 1. 1, 0, 1, 1. So 8, 4, 12, 13. 13. 13 means A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. So 13 means D. 1, 1, 0, 1. 8, 4, 12. Yeah. 1, 0, 0, 1. So 8, 1, 9. 0, 1, 1. 6. 0, 1, 1, 0 basically. 0, 1, 1, 0. Yeah, that is 6. Point 2D96 it is. So basically it is 2D96 point. What about this one? 1101. 1101. 1101. That is 13. So that is D. Now what about this? Here. Here you have only 2 number. So you will make 4. You have only 1. So I have to add 3 0. So if I am adding 3 0, so 1 0 0 0, it would be 8. So that is in 16. Are you getting this point? I hope you are understanding. 2D96.D8 in hexadecimal. And if you need to convert it to 4, so try doing it on your own. Try doing it on your own. So I will remove all the zeros which I have added. This was the number. So C is from binary to 2 to the power 2. 2 to the power 2 is 2. So 2 to I will start. I will start from the point 2 here, 2 here, 2 here, 2 here, 2 here, 2 here, and 2 here. Only till 1, 2 I need to write 1 and 2. So let's start. What is this number? 2. What is the next one? 3. What is the next one? 0, 1. 1. What is the next one? 1, 0. 2. What is the next one? 0, 1. 1. What is the next one? 0, 1. It was 1, 0. 2, 0, 1, 1. 0, 1 again 1. 1, 0 is 2. 1, 0 is 2 only. Point. Again take 2 numbers. 2 numbers. And here also I will have to add a 0 so that I can take 2 numbers. Here I did not have to add a 0 because perfect grouping was there. So here I will have to add a number. So this is 3. 0, 1 will be what? 1. And 1, 0 will be what? 2. So that we will be writing in base 4. Okay. And no number is greater than 4. You can see no number is greater than 16. No number is greater than 8. So from binary to 2 to the power n, that means 2 to the power 3 I need to convert. So I will make a group of 3. 2 to the power 4 I need to convert. Then I will make a group of 4. 2 to the power 2 I need to convert. So I will make a group of 2. So in that manner I will be proceeding. Let's check from 2 to the power n to binary. From 2 to the power n to binary. So how we will do it? So 742.32 8. So 8 can be written as 742.32. 8 can be written as 2 to the power 3, right? So each number has to be denoted in 3 digits, in 3 bits I should say. Each number should be denoted in 3 bits. Can you tell me how will you write 7 in 3 bits? That would be 1 1 1, because I have 1 2 4, 1 2 4, 4 plus 2 plus 1, 7. So 1 1 1. Or you can do 7 is there. I need to convert 7 into, this is a decimal number, right? 7 is a decimal number. Do you accept it? Yes. I need to convert 7 into I need to convert 7 into binary. So basically all the numbers will be, 7 will be denoted in 3 bits. So 7 in 3 bits will be 1 1 1. 4 in 3 bits will be 1 0 0. 2 in 3 bits will be 0 1 0. Now someone will say that, sir, I can write 2 in 0 1 only. Sorry, I can write 2 in 2 bits only, 1 0. No, but you need to denote in 3 bits. 3 bits. 3 bits. 3 bits. Okay. And what about 3? What about 3? So 3 will be 0 1 1. And what will be 2? 2 will be 0 1 0. So 3 bits here as well and 3 bits here as well. That's it. Okay. 2 will be 0 1 0. Now this 0 this 0 don't have any value, because after point, let's just say if I am writing 72.50 or I am writing 72.5, both are same, right? So similarly, this is the number, or I can write it in this manner: 1 1 1 1 0 0 0 1 0. This 0 has the value. This 0 has the value, like 70.0360. So this 0 has no value, but this 0 has the value. That's the thing. 0.011 or 0 1. That's it. So this could also be one of the option. Okay, so that's how we need to know. And 7, this was I will tell. This I was telling. 2 3 ja 6, 1. 2 1 ja 2. Remainder is 1. So 1 1 1. Okay, so let's just say if you need to denote D, if you need to denote D in 4 bits, D in 4 bits, how you will denote it? What is D? D is 13. I know D is 13. And how I can denote 13? So 8 4 2 1. 8 4 2 1. So 1 13 I need to get. So 8 plus 2 plus 1 will be 13. So 1 0 1 1. 1 0 1 1. This has place value 2 to the power 0. This has place value 2 to the power 1. This has place value 2 to the power 2. And this has place value 2 to the power 3. So 8 4 2 1. So in that manner I will write 1 2 4 8. So 13 will be denoted as 1 0 1 1. So that we will see in the next slide, hexadecimal. Now you are converting to hexadecimal. So what is 16? 16 is 2 to the power 4. So each number in 4 bit. In 4 bits. So what will be 4 bits? 8 4 2 1. So 7 can be denoted as 0 1 1 1. E. A B C D E. What is E? E is 14. And 14 can be denoted as 8 4 12. 12 plus 2 14. 1 1 1 0. So 1 1 1 0. What about B? What is B? B is 11. And 11 can be denoted as 8 plus 2 plus 1. So 1 0 1 1. 8 plus 2 plus 1. So 1 0 1 1. 1 0 1 1. And what about 2? 2 can be denoted as 0 1. Sorry. Yeah. 0 1 0 0 1 0. 2 is 0 0 1 0. 2 is 0 0 1 0. So 4 bits, these 4 bits, and these are also 4 bits. So here, now next is A. A is 10. So 10 can be denoted as 1 0 1 0. 1 0 1 0. Next is 4. 4 can be denoted as 0 1 0 0. Okay. 4 bits, and that's it. So this will be the number in binary. So 4 bits, 4 bits, 4 bits, and 4 bits. Right? Or what all other answer can be there? Will this 0 have any value? No, because if I am writing 072.960, this 0 doesn't have any value, this 0 doesn't have any value. So same thing we can do here. The initial 0 doesn't have any value. 1 1 1, 1 1 1 0, 1 0 1 1, 0 0 1 0, 0.1010, 0 1. There you go. Okay, each number in 4 bits. So each number in 4 bits. So if you need to convert this to hexadecimal, what you would do? 4 bits. 4 bits. Wait a second. 4. There is some issue. No. And here also 4, but one more 0 you need to put. Here 4 and only 2 are there, so 2 more 0 you need to put. So the same procedure is there. Whatever that you see here, now try to do it on your own. That is 4. 4 is 2 to the power 2. 2 to the power 2. So each number in 2 bits. Each number in 2 bits. So 1 1 0 0. 3 can be denoted as 1 1. 0 can be denoted as 0 0. 2 can be denoted as 1 0. 0 can be denoted as 0 1. 0.3 can be denoted as 1 1. 2 can be denoted as 1 0. That's it. That's the answer. Okay. Very easy. Very easy thing. So if there is number from binary to the power n, then you need to put n bits all together. And if there is a number from 2 to the power n to binary, then you need to put each number in n bits. Is that clear? Should be clear. If you are going from any 2 to the power any 2 to the power n to any other 2 to the power n, what you can do? There is one way that you will convert it to base 10 and then go here. Here also this way was there, okay? The way was there that you convert it to base 10 and then go here. But we know there is a special case. Here also this was the way, here also this was the way, that you convert it to base 10 and then go here. Base 10 and go here. But it would take a lot of time. So here we know something, that 3 bits clubbed, if 2 to the power 3, that means if 3 bits are clubbed, then it would be, I should remove this. So here I can write 3 bits clubbed together. 3 bits clubbed. This is the starting point. I will go here and I will go there. So 3 bits clubbed. Here I am writing 4 bits clubbed. You need to start from this point. That you need to remember. And here 2 bits clubbed, that you will get to know. Okay. So here also there was the way that you go to base 10 and then go to base 8. But that would take a lot of time. Same thing can be done here, that you go to base 10 and then go to base 4. But what we will do, we will go from here to binary and then we will go to base 4, because it would be very easy to go to binary. How we will go to binary? 8 means 2 to the power 3. That means each bit in 3 bits. Each number in 3 bits. So 1 1 1, what can be 3? 3 will be 0 1 1, and what will be 4? 4 will be 1 0 0. Point, what will be 2? 0 1 0. What will be 6? 1 1 0. That's it. So this is in binary. Now from binary to 2 to the power 4 you need to go. Binary to 2 to the power 4 you need to go. You went from 8 to this. Basically each number in 3 bits. 1 1 1, 0 1 1, 1 0 0, 0.010, 1 1 0. Okay, now you need to go to, what is 4? 4 is 2 to the power 2. So you need to club 2 bits, 2 bits, 2 bits, 2 bits, 2 bits. Here another 0 I will have to make, 2 bits, 2 bits, 2 bits and 2 bits. So 0 1 is 1, 3 1 3 0, 0 3 1 3 1. Okay, what about this? 1 1 2. That's it. Okay, so this is the answer. Well and good. So you have went from, oh sorry, this is base 4, sorry, this is base 4. So you have came from here to here, but very easily without converting it to base 10. So that is the way. So this completes our conversion. So we have seen all the conversion in 1 hour. Here I have written a summary. If you need to go from any base to base 10, then what is that? F into r to the power 0 plus e into r to the power 1 plus d into r to the power 2 plus c into r to the power 3 plus b into r to the power 4, in that manner. And here r to the power minus 1, basically this is r to the power 0, r to the power 1, r to the power 2, in that manner we will go. And here r to the power minus 1, r to the power minus 2, and r to the power minus 3. In that manner we will go. And if we talk about this, from base 10 to any base r, so we will divide it and then we will see the remainder. Here we will follow the approach from up to down, and here we will just get the integer and this part. So this is an integer part, this I am calling some alpha part. So here point alpha part will come and multiplied with r, another I1, this is I2 part. So I2 part would be coming, here some beta part would be there, so some beta part would be coming, multiplied with r, some I3 part would be coming, and then some gamma part will be there. So in that manner we can proceed, and we will follow the up to down approach. Okay, and let's just say if you divide by r, you get some, not a, you get some p here, and your remainder is q. You again divide by r, you get some m here, and your remainder is n. You again divide by r, you get some k here, and your remainder is l. And you get to know that your k is less than r now. If your k is less than r, are you getting all these points? Because we have already studied. If k is less than r, then if you further divide, you will get k and l only. So what will be your number? Your number will be k, l, n, q dot alpha, beta, gamma. That's it. That would be your number. So on the top level, I have given this thing so that you could revise it. Okay, so these are the summary only. And if I am going from 2 to any 2 to the power n, then I will club n bits all together, and I can write down my answer. Okay, n bits I will club, and then I will write down the not decimal equivalent, their equivalent here. I write down the equivalent. I should not say decimal equivalent, because in hexadecimal, let's just say some number is 15. So in that there I will not write 15, I will write f. So I cannot say I will write their decimal equivalent, I will just write their equivalent. Okay, and if I am going from 2 to the power 2, that means n bits clubbing together, and then I will write their equivalent here. Wait a second. Yeah. Or forget it, like, okay, I am going from any number to 2 to the power n to 2. So I will write their equivalent in n bits. I will write their equivalent. Each number will be denoted in n bits. 3 will be denoted in n bits. 1 will be denoted in n bits. 6 will be denoted in n bits. Here you can see this is 6. Here 5 will be denoted in n bits. Here I am denoting in 5 bits. Basically here everything I am denoting in 5 bits. This could be denoted in 5 bits. So this is actually, if this was 2 to the power 5, that means if this was 32. So from 32 to 2 I am coming. This is for the base 32. For base 32. This example is there for base 32, and here I am clubbing 3 bits, so this example would be there for base 8. Okay, so if I am clubbing 3, then what I will get? So this would be 1, 2, 4, 5, 6.101, 5, 1004, and 100 and 100 again, 100 again, that would be also 4. So that would be for base 8. So that is the example. So if you just read these 2 slides, then everything is clear. So only these 4 methods we have studied. Any number to decimal, any decimal to any number. With this effect you can change anything, and from 2 to from 2 to 2 to the power n, and from 2 to the power n to 2. Now you will be able to convert any number to any base. Let's solve some problems. So for a particular number system, 24 plus 17 is equals to 40. Find the base of the system. 24 plus 17, what is that? 24 plus 17. 24 plus 17 is 41. But here they are saying that it is 40. That means something is different. Something is different. That means what they mean to say is that 24 in base r plus 17 in base r would be equals to 40 in some base r. We do not know these kind of calculation, but we know one thing, that we can do decimal addition. You know 3 plus 2 is 5. This much things you know. 23 plus 22 is 45. This I know. So what I will do, I will convert this number into decimal. How I can convert this number into decimal? What will be 24 in decimal? 4 into r to the power 0 plus 2 into r to the power 1. What will be 17 in decimal? 17 into r to, sorry, 7 into r to the power 0 plus 1 into r to the power 1. And what will be 40 in decimal? 14 into r to the power 4 into r, sorry, 0 into r to the power 0 plus 4 into r to the power 1. So this calculation I know now. 4 into r to the power 0 will be 4 plus 2 into r to the power 1 will be 2r plus this is 7 into r to the power 0 is 7 only. This will be r, this will be 0, this will be 4r. So I know this calculation now because this is in decimal. Everything is decimal in now. Everything is in decimal. Our target is to find this r. So we can find this r. What that would be? From here I can get to know that my r is equals to 11. So here the base is 11. Okay, the base is 11. Root 41 is equals to 5. Find the base. So if I do that, 41 will be equals to 25. Step is wrong here. Why this step is wrong? You cannot do any calculation. Your first target would be always our first target would be convert into decimal. Convert into decimal, then perform the calculation. So first you will convert to decimal, then you perform the calculation. Okay. So first convert into decimal, then you perform the calculation. So root will be there as it is. Root is there as it is. How this will be converted? 1 into r to the power 0, that will be 1, plus 4 into r to the power 1, that would be r, 4r. 5 into r to the power 0. 5 into r to the power 0 will be 5 only. 5 into r to the power 0 is there. That would be 5 only. So 1 plus 4r. This is in decimal now. This is in decimal. Under root 5 into r to the power 0 is 5. This is also in decimal. Now all numbers are in decimal. Now you can take the root. So what we will get? 1 plus 4r is equals to 25. So r is equals to 24 by 4. That is 6. So the base was 6 here. So this number was actually 1 plus 24. And if you take the under root, you will get the 5. And 5 is there. If you write it in decimal, if you write it in base 6 or you write it in base 10, it would be same only. And one more thing I need to take care. What is that? That all these numbers, all these digits 4, 1 and 5 all are less than 6. This also I need to take care. Why I need to take care that? 4, 1 and 5 all are less than 6, because in my, if my base is 6, then my number has to be lesser than 6. So 4, 1, 5 all are less than 6, then this answer is acceptable. Okay. Now some people will say that sir here plus minus would come. Now someone say that if we take the under root here, so no plus minus would come. No one will say that. I am taking the square, not under root. So yeah, r would be 6 here. Only one answer is possible, that is 6. Let's see the next one. In a particular number system, the roots of the equation is this. You need to find the base. So root of the equation is this. Roots are 3 and 6. So all these numbers are also written in some particular number system. Are you getting this point? This 11 is not 1110. Now this 11 is 11r. Okay. This 11 is 11r. 22 is 22r. So what they are saying? And we can do something. Let's change this question. 3 and alpha is 3 and alpha. Find the base. In a particular number system, one of the roots of this is 3. Find the base. This is the question now. Okay, only one root I have given. So now it would become more interesting. So what is the root I have? root that I have is 3, but this root is 3 base r, that is some other number system. So what do I know? Multiplication of root, multiplication of roots would be what? C by a. Do you know that? C by a, 22 by 1. Let's just say if there is an equation x square minus x square ax square plus bx plus c is equals to c. So what will be the roots, or what will be the addition of the roots? Minus b by a. And what will be the multiplication? That would be c by a. So I hope you remember this thing. Okay, in 10th class we have studied it, where alpha and beta are the roots. Alpha plus beta is minus b by a and alpha into beta is c by a. So multiplication of roots will be c by a, that would be 22r. Okay, 22r, and addition of roots is minus c by a, minus b by a, minus b by a. So that would be 11r. Okay, 11r. Now one of the root is 3. Let the other root, be alpha r. Other root is alpha. So what I can write? 3r into alpha r is equals to 22r. Say yes or no. I will not perform any calculation now. First my target will be to convert it into decimal. So 3r will be in decimal. What that would be? 3 into r to the power 0. That would be 3 only, right? 3 into r to the power 0 it would be. So it would be 3 into alpha r, I don't know. What it would be? 2 into r to the power 0, 2, plus 2 into r to the power 1, 2r. So I am assuming alpha r as x. Okay, I am assuming alpha r as x. Alpha r is x. So here I am writing alpha r is some x value, so that it is easy for me to write. So alpha in base r is some x value. So 3x is equals to 2 plus 2r. This is one equation I am getting. What other equation I can get? Addition of roots. Addition of roots. So 3r plus alpha r would be equals to 11r. Again I will not perform any operation. First I will convert it to decimal. So what I will get? 3 plus x is equals to 1 into r to the power 0, 1, plus 1 into r to the power 1, r. So 2 equations I am getting. This was the first one, this is the second one. So what I can do? I do not need x. I can replace the value of x. I do not need x. So what will be the value of x? So here I can see x is equals to r minus 2. X is equals to r minus 2, right? This 3 goes here, x is equals to r minus 2. And from here if I see, x is equals to 2 plus 2r by 3. So 2 plus 2r by 3 is equals to r minus 2. So 2 plus 2r is equals to 3r minus 6. So r is equals to 8. R you are getting, that is 8. So answer is 8. So base is 8. Now if someone asks what was the other root? What was the other root? What was the other root? Other root. I am asking what was the other root. So here this is 3 plus this x I need to find. Sorry. Okay. 3 plus. Yeah, wait a second. Look, if I have converted this all these values, if I have converted 3 into base 10, this 3 into base 10, then certainly I have to convert this alpha into base 10 as well. Then only I can perform the operation. Let's just say there is base 10 and here there is base 8. Then how I can perform the operation? So alpha r is equals to x in base 10. Look, I have converted 3 into base 10. So I will, and 22 into base 10 as well. So I will convert all the numbers into base 10. 3 into alpha r would be x. So alpha r, if I am writing alpha r is equals to x, that means I am writing alpha r is x in base 10, right? So that is x in base 10. Eventually I don't need alpha. So that I will eradicate. So 3x is equals to 2 plus 2r, and here it is 3 plus x is equals to 1 plus r. So x value you are getting is r minus 2. X value you are getting is r minus 2 here, and then I put r minus 2 here, and I get 2 plus 2r by 3, so 3r minus 6, and from here I get r is equals to 8. So now I will put my r in this particular equation. 3 plus r is equals to 1 plus r. In this equation I am putting 3 plus x. 3 plus x is equals to 1 plus r. So 3 plus x would be equals to 1 plus r. R is 8. So x is equals to 6. 9 minus 3. So x is equals to 6. So this is the other root, and this root is in decimal. This root is in decimal. So other root is 6 in decimal. In decimal I am getting the other root, that is 6. In base 8 as well, this answer is in decimal. So in base 8, alpha r is equals to alpha base 8 is equals to 6 in base 10. So what that value will be in base 8? What do you think? You need to convert 6 from base 10 to base 8. My question is 6 from base 10 to base 8. So what you will do? 6 and divide by 8. So what will be the remainder? 6 only. Sorry, how it will be divided? 0 time. And what will be the remainder? 6. Basically 6 is less than 8. So it will be the same only, no? You can go upward. So 0, 6 only you will write. So 6, if this answer is in decimal, so that means this answer is 6 with base 10. So what will be the value of alpha? That would be 6. This answer is in base 8. So although luckily here our roots were here, luckily we got 6 value here. If we had got 11 here, let's just say my other root would have come out to be 11. Then what would be my answer? Will that be my answer? No, that would be wrong. Because 11 you are getting in base 10. Now your task would be to convert 11 into base 8. So 1 and 3. 1, 3. So answer would be 1, 3 in base 8. Are you getting this point? So the complexity start from here, that if you have converted everything into decimal, that means this x is also decimal. That means this alpha r has been converted into decimal. Okay. And if alpha r is converted into decimal, that means this is also decimal. So from here, if you are getting r is equals to 8, so if you put r equals to 8 here, that means x is equals to 6. So this answer you are getting in decimal. Now your task is to convert this decimal into base 8, because your given base is 8. So you need to check the option if the given options are there in base 8 or base 10. So the answer you are getting, that is there in base 10. So you need to convert it to base 8. Luckily we will get the same answer. So from here I am going here. From here I am going here. Okay. So that is a lot of good points I have explained in this particular question. I hope you got it. Right. So these kind of questions you can expect in your examination. These are very good problems, and these kind of questions can come in your examination. Let's see the next one. 43x is equals to y38. You need to find all possible combination of x and y. So 3 plus 4x. Do you agree to this point? X 3 into x to the power 0. 3 into x to the power 0 plus 4 into x to the power 1 would be equals to 3 into 8 to the power 0 plus 8 into y to the power 1. So 3 plus 4x is equals to 3 plus 8y. So from here I am getting y is equals to x by 2. But if you have given that 43x is there, that means x has to be greater than x has to be greater than 4. X has to be greater than 4, and x will be integer for sure. That means x can start from 5, 6, and in that manner it can go, right? What about y? Y3 8. That means y has to be less than 8. Say yes or no? Y has to be less than 8 because this will be the bigger number. So y can go like it will be less than 8. So it can have values 7, 6, 5 and so on till 0. Negative number cannot be there till 0. So 5, 7, 6, 0. Now if x is having, and all should be integers, all should be integer, that means all should be belonging to natural number. Now if x is 5, then y will be 5 by 2, not acceptable. If x is 6, not acceptable. So this is wrong. If x is 6, x can be 6, right? Then what will be y? Y will be 6 by 2, that is 3, acceptable. Y will be 6 by 2, that is 3. 7, 5, 7, 6, 5, 4, 3, 2, this is acceptable. If x is equals to 7, then what will be y? Y will be 7 by 2, not acceptable. If x is equals to, let's keep this question a bit downward. If x is equals to 8, then y will be equals to 4, acceptable. If x is equals to 9, then y will be 9 by 2, certainly not acceptable. If x equals to 10, then y will be 5, acceptable. If x equals to 11, then y will be 11 by 2, not acceptable. And if x equals to 12, so in that manner we will go. So you must have got the idea, right? That thing is, if x is 5, then it is not acceptable. So I am writing in xy order. So if x is 6, then y will be 3. X is 6, y will be 3, that is acceptable. If x is 8, y will be 4. If x is 10, y will be 5. And if x is 12, y will be 6. And if x is 14, y will be 7. Till that point only it will be acceptable. Because if x is 16, let me write it here. If x is 16 here, then what will be y? Y is 8. But y cannot have any value bigger than 7. So this will also not be acceptable. If x is 16, then y will be 8. So x can take, so we will start with x. Okay, we will start with x. So x can be 5. So y will be 5 by 2, not acceptable. X is 6, acceptable. 7, not acceptable. 8, acceptable. 9, not acceptable. 10, acceptable. 11, not acceptable. 12, acceptable. 13, not acceptable. 14, acceptable. After that, nothing will be acceptable because y will be greater than 7, which cannot be possible. So these are the expected values. So this is the answer. Okay. Now let's take this question here. Let's take this question here. Okay. Find the possible number of ones. क्या हो गया भाई इसको? इसको आना ही नहीं है यहाँ पे. Find the number of ones present in presentation of 3 into 512 into 7 plus 7 into 64 plus 3. What you will do? You need to find number of ones in binary presentation of. So what you will do? First you will convert it to decimal, because all these are in decimal. So first you will convert it to decimal and then you convert it to binary. Is that the way you will be doing? No. So how you will be proceeding? So let me add a page. So what is the given number? The given number is 3 into 512 plus 7 into 64 plus 3. One thing I can sense here is that this is 8 to the power 2, right? This is 8 to the power 2. This is 8 to the power 2. And this can be written as 8 to the power 0. So there has to be 0 into 8 to the power 1. That's why there is no term of 8 to the power 1. Plus this is 3 into 8 to the power 0. What if this is 3 into 8 to the power 3? Let's check if 512 is 8 to the power 3. So yes, 512 is 8 to the power 3. So here the first thing that I noticed was 64, and 64 is 8 to the power 2. So what I get to know here, that this number has place value of 8 to the power 0, this has place value of 8 to the power 1, this has place value of 8 to the power 2, and this has place value of 8 to the power 3. That means this number is 3703 in base 8. Say yes or no. If you need to go from here to here, you can go, right? 3 into 8 to the power 0 plus 0 into 8 to the power 1 plus 7 into 8 to the power 2 plus 3 into 8 to the power 3. Say yes or no. If I need to go from here to here, basically I will write 3 into 8 to the power 0 plus 0 into 8 to the power 1 plus 7 into 8 to the power 2 plus 3 into 8 to the power 3. This is how I will write it, right? Are you getting my point? Now I am going from here to base 2. That means this 8 is 2 to the power 3. So I need to denote all the number in 3 decimal. I need to denote all the number in 3 bits. So 3 can be denoted as 0, 1, 1. 7 can be denoted as 1, 1, 1. 0 can be denoted as 0, 0, 0. And this 3 can be denoted as 0, 1, 1. So how many ones are there? 1, 2, 3, 4, 5, 6, 7. So answer is 7 ones are there. 7 ones are there. So this is the answer. You can solve same kind of problems here. You need to denote this number in base 32. So what do you think? This I can sense that this is 32 to the power 2. What this could be? 32 to the power 3. Yes. So this is m into 32 to the power 3 plus j into 32 to the power 0. There has to be 0 into 32 to the power 1 plus 3 into 32 to the power 0. So this would be mj03 to the base 32. Right? Very easy problem. You can solve these kind of questions. Okay. 41 by 3 is equals to 13 in some number system. Find the base. You can do it on your own. In some number system, 41 by 3 is equals to 13. You need to find the base of the system. So I will not perform any calculation before converting into decimal. So this would be 4r plus 1. This would be the same, 3 into r to the power 0. This would be 3 plus r. So 4r plus 1 would be equals to 9 plus 3r. So r will be equals to 8. So this is the answer. So r is 8. So you can perform the calculation. If r is 8, 41, 8. So that would be 8 into 4, 32. That would be 33. 1 into 8 to the power 0 will be 1. 8 into 4, 32. 33 divided by 3. What you will get? 11. But you are getting it in decimal. 11. This performance you are getting it in decimal. But what answer they are giving? 13. So 13 in base 8. That means 3 plus 8. So 11 only you are getting. So the answer is same. So you can cross verify as well. Okay. Cross verify just putting 8 here. So if I put 8 here, I will get the same answer. 55 by 5 is equals to 11. What is the possible base? So 55 by 5, that is 11. In our normal calculation, the answer is 11. That means this is the answer. No, it could be other cases as well. Here it cannot be 3. It cannot be 5. Why? Because if I am saying that some number is there in number is 55 5, this number is 5 in base r, and this number is 5 in base r, and so r has to be greater than 5, r has to be greater than 5, right? R has to be greater than 5. So what I will write here, 5r plus 5 divided by 5 is equals to 11. What that would be? R plus 1, 1 into r to the power 1 plus 1. So 5r plus 5 is equals to 5r plus 5. So always true, always true, always true. So for any base r greater than 5, for any base r greater than 5, 55 by 5 will be 11. So this answer is also correct. So if there were option, let's just say if there were option E that was 7, then this will also be have been correct. If there was option B that is 298, if the base is 298, then also it would be correct. Okay, any base could be there. For any base greater than 5, that would be the correct. Okay, so that's it. This is the end of our first lecture. There we studied about number system. So I hope till the end you are finding it interesting. A lot of good amount of problems we have solved, and a lot of good problems also we have solved. So nothing apart from this can be asked from this particular topic. Okay, and the number system is a important topic. There is very high chance that they will ask questions from this particular topic. So you cannot skip it. And I hope in this 1.5 hours you must have understood a lot of concept. So before moving on to the next lecture, I strictly advise you to revise it once. Just revise it, whatever that we have studied here. Just revise everything, you can revise it. Okay, then you can move to the next chapter. Right? So let's move to the next chapter. Not next chapter, sorry. In the next lecture, we will study about binary operations. Not only binary operation, we will study about all the operation, octal operation, hexadecimal operations, even the decimal operation, simple addition, subtraction we will study. So now we are going to study subtraction and addition. So in the next lecture, we will see that. Okay then, thank you very much.